Good morning, everyone. I am Vinita, working as an associate professor in the Department of Electrical and Electronics Engineering, RMD Engineering College.
Okay, today I'm going to explain about shaded type relay. Actually, this shaded type relay that works on the principle of induction principle. So before going into shaded pole type relay, let us see the principle of induction type relays. Actually, in induction type relays, it works on the principle of normal induction motors. So we all know that for the working of normal induction motors, it requires two fluxes. So those two fluxes interact each other and thereby producing an resultant torque. The same principle that is worked in this induction type relays also. In this induction type relays, there will be two electromagnets. Between those two electromagnets, a metallic disc is provided, and this disc that is free to rotate between those two electromagnets, and so there will be an electromagnetic torque. So the same principle, this induction relay which is working, that is the principle of induction motor. These induction type relays are classified into three types. First one is shaded pole relays, second one is Watt-Hour meter relays, and the third one is induction type relay. More in this, all the three types, I am going to explain about shaded pole type relays. So this shaded pole type relay, this is also same as induction motor, shaded pole type induction motor. This shaded pole type induction relay, which consists of only one C-type electromagnet, and in this electromagnet, actually, the coil which is wound in this magnet, and here therefore in this magnetic pole phase, which is divided into two actually. One is nothing but unshaded portion, and then is shaded portion. And in this a shaded portion, a copper shading ring is provided. So why we are dividing this into two, that is two shapes, that is shaded and unshaded parts, is nothing but in order to produce two fluxes. In between this electromagnet and metallic disc, normally we'll be using aluminum disc that is provided between these this sheet C-type magnet, and this disc is free to rotate between this magnet. And as I said, explained earlier, this is a C-shaped electromagnet, and it is divided into two halves. One is a shaded portion, and another one is unshaded portion. So whenever the supply is given to this electromagnet, what will happen? There are two alternating fluxes will be produced, and these two fluxes are displaced in space and time, and these two fluxes that will interact each other, and so interaction of fluxes that will be producing eddy currents. These currents that produces the resultant torque, and so this torque that causes the disc to rotate. So here we can see here, this is an unshaded portion, this is a shaded portion. So whenever the supply or the coil is energized by means of an alternating source, it will be, that is two fluxes, phi u and phi S will be created. Phi u means the flux produced in the unshaded portion. Phi S is nothing but the flux produced in the shaded portion. These two flux will interact each other, and the resultant flux is produced, and this will be created the resultant force or torque. So due to this force, the disc will be rotating. So this is the working principle of shaded pole type induction motor. So whenever the disc starts rotate, what will happen? It will be that is this relay which operates the circuit breaker. So for this shaded pole type of relay, we can draw the phasor diagram. So in order to draw the phasor diagram, here the flux has been taken as the reference vector. So in the shaded pole type induction motor, we all know that two fluxes phi u and phi s will be displaced by an angle of alpha. This alpha, which is called a split phase angle, this we have studied in single phase induction motor. Since the flux phi u, that is the flux in unshaded portion, will be created first, and so that this flux phi u that leads the resultant flux. And similarly, the second flux phi s, that is the flux produced in the unshaded portion, will be created next, and so that this flux phi s will be lags behind the total flux phi. Now, the angle between phi u and phi s, which is represented by alpha. Next, we need to draw its corresponding voltage, that is the induced EMF EU. So once the flux is created, obviously, as per the induction motor principle, the EMF will also produced. Now, the resultant induced EMF, that is EU, that will be lags behind the flux by an angle of U, because since it is an induction motor, the induced EMF, because due to flux phi u, the induced EMF will be created. So this induced EMF, which lags behind the flux phi u by an angle of 90 degrees, and this induced EMF, this will be drives the current IU through the circuit. This is as per transformer principle. So this current IU that lags behind the induced EMF EU by a small angle beta. Now we have drawn all the vectors for unshaded portion. Similarly, we can draw the vectors for shaded portion. Here we have the shaded flux phi x. This flux phi s, that will be responsible to produce the induced EMF ES. Therefore, this induced EMF ES lag behind the flux by an angle of ES. Similarly, this induced EMF, which will be driving the current through the shaded portion. Therefore, this IS that lag behind the voltage by a small angle beta. Here, first the flux phi u will be created, so that this flux phi u that will be leading the resultant flux phi by an angle, by a small angle. Since this is created first, and this will be producing its corresponding voltage, which in turn produces the current IU. Similarly, the shaded portion flux phi s, and then the resultant induced, then the induced EMF, and then the current IS. Therefore, the induced EMF ES lags behind phi s by an angle of 90 degrees, and this ES that lags behind IS by an angle of beta. Since this is not purely an inductive circuit, because we have a copper shading band, so that we cannot say that the phase angle between ES and IS, which is not exactly 90 degrees. There is a small, due to the presence of a resistance, that is a copper shading band, as well as the inductive circuit. The angle between ES and IS is nothing but beta. So this is the phasor diagram for shaded pole type induction motor. Now, for this shaded pole type induction motor, we can derive the expression for torque. So as per the general equation, T is proportional to phi1, phi2 into sine alpha. Now, we have two fluxes, phi s and phi u. We can replace the torque equation by T is proportional to phi s phi u into sine alpha. This is nothing but torque. Therefore, we can rewrite the expression as T is proportional to I square into sine alpha, because the phi s and phi u both are proportional to I. We know that in case of motors, the flux will be proportional to I. Therefore, we can write the torque equation as T is proportional to I square into sine alpha. Therefore, we can write T is equal to K into I square. That is the torque produced by the induction type relay, shaded pole induction type relay, which is proportional to square of the current through the circuit. Thank you.